Hey, welcome back to Mechanical Pros. Today we're going to be talking about a counterflow cooling tower, in this case an Evapco counterflow cooling tower, and we're going to discuss all the controls and the devices in that control circuit. So I'm going to start here with our control panel. As you can see on the front of this panel, we have our high voltage disconnect switch. We're either going to have 208, 230 volt power or 460 volt power coming into this device. Controlled right on this disconnect switch. You got a couple other things that are good. I got a visual indicator if my Basin heater is active, and also an on-off switch for that heater. Okay, so now we'll look inside this box here. As you see, here's my high voltage disconnect. I got my high voltage power coming in here. My contactor that is feeding my electric Basin heater, which we're going to talk about that in just a minute. But this is a high voltage device coming off of this contactor, high voltage coming in and out. All these other devices here are going to be low voltage. So we got some circuit breakers, contactors, fuses, and our disconnect in there. We'll leave that closed and we'll leave it turned off. Now, as we talk about this Basin heater, the Basin heater's purpose in this application is right behind me here is what we call the tower sump or the cold water basin. This portion of this tower is always full of water right here when the tower's in operation, about up to this water level. If you see this pipe, this is my overflow pipe. If my water level gets too high, it'll overflow and go out the drain. So you don't want it that high, but that's what that device is for. In case you're overflowing your tower, it's not spilling out of the side of the tower and it's going to go out down the drain. So here's our water level mark, roughly somewhere right below that. Here's my thermostat that is in a Basin well inside this cold water sump, and that's looking at my temperature. This is what's controlling my heater to come on and off, and here's my thermostat. Right now you can see that, I don't know if you can catch that in the camera, that dial's set to about 45 degrees. So if the water inside of this sump gets below 45 degrees, it will energize this high voltage Basin heater to heat that water back up to 45, and then it'll shut off. Now there's another component that's critical to that Basin heater operation, and it's this guy right here. That's a float switch. It's just an arm inside the tower that makes and breaks that way. So as the water level rises, the float switch comes up and it makes a contact and it says, I'm safe to start this heater. It's a very important part. The reason for that, you would never want to run this heater without water in the Basin because the heater will burn up. It needs water to keep it cool. So if this switch were defective or somebody had jumped it out, it's not installed and working properly, you got the potential of your tower being almost out of water, banging on this electric heater, and then you smoke your heater, and then you're in bad shape here. So the three components that are involved in this for heating the Basin water inside that tower are the heater, the thermostat, and then my safety float switch that lets me know my tower's got water in it, I'm okay to turn this heater on. So very important to also check these devices when you're doing your annual maintenance on these towers. Make sure these components are functioning right. If you come across one and your heater's busted, I'm definitely checking these first to make sure I don't have a problem there, because again, that heater should always be underwater protected. Everything else is pretty straightforward, but as simple as this may or may not sound to some people, it is critical and it gets missed a lot. The wiring sometimes doesn't get terminated to these devices correctly, and then you have issues down the road. Maybe the heater's never coming on. Cold winter time, you can possibly freeze your sump and have a lot of issues there. We talked about making sure we got water for our heater, but how do we maintain the proper water level? Now, we talked about our Basin heater and it's keeping our cold water sump from freezing. But we've got this external device that is field installed, which is called our cooling tower makeup water line. So basically, when my tower sump starts evaporating water, which is normal, we're running heat across this thing, we're circulating the water, pulling the air, outside air across it, we're going to lose some water to evaporation. We have to replace that water with what's called cooling tower makeup. This is the most common failure we see on these cooling towers in the wintertime. This is field installed and it's called heat trace. Some of you may or may not be familiar with heat trace. It's basically an insulated wire that you wrap around the pipe before you insulate this pipe. It'll be set up on a thermostat and it will come on if the ambient temperature gets below the desired setting you put the dial at, typically at least 35. And all that's doing is keeping that pipe warm under the insulation, because the water is not always flowing. There's a valve that opens and closes, so when the water stops moving, it's gonna freeze a whole lot quicker. And when we get in the wintertime, this item's missed all the time. It may be there, but it doesn't work, you know? So another thing, you really wanna make sure you check that heat trace when you're doing your preventative maintenance, because if you're doing the maintenance and then it freezes and busts in the winter, guess who's gonna be paying for that? So always check that heat trace, make sure it works. This happens all the time. It freezes and busts, and then when it warms up outside, nobody knows it's busted until they see their water bill, and it's sitting out here flooding the ground under the tower. So a really simple thing to check, but it gets missed all the time. One other important one to heat trace, doesn't get hit all the time, is this brass valve. This is a drain valve. So if I wanted to drain all the water out of this tower, I would open this valve. Therefore, up to the center of this valve, I've got water here. It's a brass valve. These freeze and bust quite a bit too. So another good practice, heat trace that guy as well. Let's move on to how do we control the water level in the cooling tower. We know we need the water level to be right below the overflow pipe that we talked about earlier, roughly somewhere in here. And we control it with this device. This particular is a Warwick brand, and it's an electronic water level controller. So basically, in a nutshell, inside this pipe, you can see this one coming out here. So there's my tower water running through here, and the water inside this pipe is right at the top level of the tower. Well, down in here, I've got 3 electronic probes. One probe tells me my water needs to fill. The other probe tells me my water's too high, and the center probe is where my water needs to be at. So you got 3 probes there. There's also what's called a 5 probe. Does the same function as this tower, except it has 2 additional probes, and those are alarm points for a building management system. So if you ever open one of these guys up and you see 5 probes, they may or may not be using those other 2 probes, but 2 of them are dedicated to generate an alarm to the building management system saying my cooling tower is low on water. There's one other way to fill this tower called a mechanical float valve. Very similar to what you'd see when you pull the top off your toilet tank and you got that ball float in there. That's exactly what we're doing here. We got a ball float that's adjustable on a rod, and you manually set where you want your water level to be, and then the tower fills. When that float drops, the valve opens, we fill the tower. As the float raises with the water level, gets to the desired level that you've manually set, it shuts off the water flow. One thing to be cognizant on a manual float valve, you have to have a pressure regulating valve in front of it. You can't hit these manual float valves with more than 45 psi of water pressure, or it'll cause the valve to leak. You got a little more grace on these electronic. I think that solenoid will take up to 90 to 100 psi, somewhere in that range. But if you've got a manual float and you see it's always leaking by and it just won't, you can lift the float up, it still doesn't stop leaking by, more than likely the valve's defective because you've been hitting it with too much water pressure. That's when you go back and trace the water line back into the building and try to find if they have a PRV installed or not. And these are the things I always want to check when I'm doing my annual maintenance on my cooling tower, to make sure all these components function properly. And then if I'm doing a quarterly maintenance in the wintertime, I'm obviously not going to be draining the tower if I'm just doing a running inspection, but I always want to make sure my basin heater's operating as it should and my heat trace is functioning if in the cold weather months. That'll save the customer a lot of headaches down the road.